Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail bin Fuad.
Assalamualaikum. I am Tanbir Mahmud Hussin.
I will be explain about the introduction. The task given is to help the Sentinel to hunt down mutant that have the X gene, and also the human with the potential to have mutant offspring. So this Sentinel is capable to detect the human and mutant using their mutant detection device. So there are requirements for the Sentinel that can get the highest value group of mutant and also maximize the capacity it can carry within the weight limit.
So now I am describing about the methodology. In these sections we used a process to break a big problem into a small problem. So in that case we evaluate our algorithm by inspiring a dynamic approach. So we consider the value and the weight with the 2D array. Our main intention was to pick the best value with the least weight. So we just inspired from the dynamic approach. In dynamic programming approach is most likely as divided a concurrent method, but dynamic programming combines the solutions of the subproblem and solve each of the subproblem once. The solution is then stored to avoid recomputation of the result when need later. This simple optimization reduces the time complexity from the exponential to the polynomial. So we are following this step. Creating a matrix with the dimension of matrix weight plus 1 by total item plus 1. Then generate the nested loops and start from the second element of the items until total item plus 1 and second element of the weight until the max weight. After that, compute the capacity with the current weight. If the capacity is greater than the current weight, then return the max value with current. So however, our execution times is in time minus start time, so we can get the execution time. Moreover, accuracy, our optimal value with the expected value into divide by expected value into 100, where the expected value was 1313. So let's move to the coding. So I will describe the coding now. So this is our coding part. I import time for execute the time to show the execution time. So I just create two arrays, which is value and weights. So I include all the values in values and all the weight of the items is weight. So first of all, I include the total item, which should be 32, which is given, and the max weight is 65, which also given. So in first I just declare accuracy is 0 and execution time is 0. So our expected optimal is 1313, which is given. So I just create a matrix where all the elements of the matrix is 0, and we start from the second column and second row. So in that case we ignore first one, because first one of all the elements are 0. So we just consider I in range of max weight plus 1, and the another one is total item plus 1. So now I am creating a nested loop which actually calculate our optimal value with the minimum weight. So for using for loops, so it's start from 1, because 1 is the second index. First index was 0, so we start from the second index. So second index to the total item plus 1, and then max weight. For finding the max weight, it should be second index to max weight plus 1. So first of all, max value without currents equal to matrix of item minus 1 and into capacity. So in that case, maximum value without current we declare as 0. So weight of current equals to weights item minus 1. So we compare the weight of current to capacity. So in that case, our max value with current equals to values into item minus 1, and remaining capacity is actually means the what are the gap between 65 and then now. So remaining capacity equals to capacity minus weight of current. So max value with current plus equals to matrix of item minus 1 and into the remaining capacity. So now we just consider our max value without current and max value with current. Which one is greater? That is the basic things, so we can collect our optimal value. So this is the way, and in last we just in the time to stop our execution time. So execution time should be in time minus start time, then we can find our execution time. And another thing, we just show our accuracy. So in that program, accuracy equals to our main optimal value divided by our expected optimal value into 100. So we can get our accuracy, and our optimal value is this. So now I am running this program. So let's run the program. So you can see the execution time is 0.001 second, and the accuracy is 100%. The optimal value is 1313. So in that case, in brute force it needs 14 minutes and more to get the optimal value. So our algorithm is more efficient to find our expected optimal value with the minimum time. So this is our main algorithm. So that's all for coding.
Okay, so for the evaluation, as we run our program, the result of the program, we achieve the optimal value, which is 1313. So our optimal value is the same as the expected optimal value, which is also 1313. So, and we can see that the runtime for this program to execute is more faster compared to brute force, where brute force takes 14 minutes to get the optimal value. But in our program, when we use or we implement this dynamic programming approach, we only take 0.003 second to 0.05 second in range. Sometimes we get 0.03 and sometimes we get 0.05. And to conclude that our assignment, we can see that when applying the dynamic programming approach, it reduces the time complexity and improve the performance. So our optimization problem can be solved much faster, and also doesn't need a lot of time to execute compared to the brute force approach, because our program only takes a millisecond to solve.